Hi, my name is Jana. I'm the technical product manager of Qubit's Point Science software, and today I'd like to show you how you can create a true-to-scale image plan by unwrapping a cylindrical part of a building or a facade. You can see that I have already opened a drawing with a point cloud from a scanned facade, and what I like to do is I like to fit a cylinder here in order to unwrap photographs of this cylindrical part of the facade into the plane so I can measure true length in the unwrapped imagery. So first of all, I will go to my Points and Heritage ribbon, and I will set the point cloud parameters right here, and I will measure them with the cylindrical auto measure. And to do so, I need to clip a cylindrical part of the point cloud, and I will also try to remove the bad parts. So I will clip once more, crop option. We really just take this part. It's important not to have the noisy parts in there for the auto measure command. I can close, and if I press enter, it starts the auto measure process. I get nice parameters, can say OK. Then I'm back here, and all I need to do now is go in here and say I want to fit cylinders, and I have different options. I can just pick 2 points on the cylinder surface. I could crop to the visible points of the cylinder, or I could snap certain points on the cylinder surface by the object snap. This with the 2 picking points is the most automatic way, and we just added the other options in case that the automatic fitting might fail. So let's choose picking 2 points on the cylinder surface, enable the object snap, pick 1 point, pick another point. So now you can see the cylinder has been fitted very nicely to the object. Let me just navigate a little bit further. You can see here. The only thing is, for our unwrapping purposes, it's still quite small, and what I will do is I will stretch the cylinder to the extents from the bottom to top of the facade. Let me just turn off the point cloud. Let me grab this handle and turn on the point cloud again. And with the object snap, I'll snap the bottom. And I will do the same thing with the upper handle and snap 1 point up here. And we have stretched now the cylinder along its axis to the extents of the facade. What I will do now is I have also taken some photographs of this part of the facade, and I will use Points and Heritage to insert the images, the oriented images. I go to Image Modeling, Insert Oriented Image, and I will select the 2 images where I have the orientation information. The images have been inserted right here. If we have a look, we have one, and we have another one. And as I'm only interested in this part of the image, I will use the clipping tools for imagery to clip them to this extent, so when unwrapping we will ignore the rest of the photograph. So I go to Clip Image under Image Computation, and now I have to select the image I want to clip. like this one. And let me turn off the point cloud meanwhile. And I want to pick points rather than a polyline. Go down here, close, and there we have the clip. Confirming with enter, and do the same for the next image. Select the image, P for points, and go in here, clip it to that part only, so we have then a smaller image frame, and we are only interested in this part. Close, enter. Alright, so now we've got the cylinder. We don't need the point cloud at the moment. We've got the cylinder as a surface, and we got the photographs. And now we can go to image computation and choose the unwrap cylinder command. We select the cylinder first, cubit cylinder. We want to, it's the outside of the cylinder which we have and which we want to unwrap. And we want to split the cylinder open to unwrap it, so we need to select a point inside an oriented image. I can zoom in here, and I want to split it that way that it opens on the other side, so I pick a point here, and cylinder will be split just across the cylinder axis. So further settings for unwrapping ask me where I want to place the unwrapped imagery. I can place it parallel in the XY plane of the user coordinate system, or I can place it at the cylinder. I will select this option, and as my facade does not cover a whole cylinder but only a part of a cylinder, I will use the second option relative to the reference point. The reference point is the one I just clicked above the small window. And knowing the dimensions of this facade already from the point cloud, I will enter a width of 2.3 meters left and right of the reference point. Say OK. If I would have geometry on top of the cylinder, which I have drawn on top of the cylinder, I could select this geometry as well to be unwrapped, but here we just have the photographs and want to unwrap the image data. Now I have to select the image data. Note, I could also unwrap point clouds. We will have a look to that later. And now I just select both images. Press enter to confirm selection. Shuffle this to the top. And now I have different overlapping options. I could use the image with the best angle of incidence. I can average the image data according to the angle of incidence. I can use the image at the top of the list. I'll select this option over here. OK. And I can also apply automatic brightness correction if the images have been taken with different lighting, but we recommend taking photographs always with a good distribution of light, no shadows, no bright light and stuff. I set the selected image as the reference image, and I can define a reference region inside my image. Close. And having done these settings, I can just choose a file name for the exported file, and I will select a PNG file, has a better compression and TIFF, and yeah, let's call it just facade northwest unwound. Okay, save this. and I will start to compute the projection right now. And you can see software is computing first the cylinder projection. If you look to the lower left, you can see how it's calculating. So already 50% of the cylinder projection calculated. And yeah, nearly done. So this is really real life, and now we are asked to if we want to switch to the plan view of the unwrapped image. I just say yes, and you can see it's put the the software has put the user coordinate system right to the unwrapped image. If I add the point cloud, you can see we are right at this area of the facade. Let me switch back to the plan view. So what I have now here is a true to scale image plan of this cylindrical area of the facade. I could now start drawing the facade plan on top of it if I want to, or if my deliverable is just the image plan, I could add some dimensions if I want to. So I will add some dimensions, but on a different layer than layer 0. Add geometry layer and go to annotations, dimension the width of the window, for instance. Disable the object snap, pick here, pick there, and I have the true length of this window, or I can annotate the height of that small window down here. And please note that really only the objects which were directly on the surface of the cylinder will be true length and true to scale. Everything which is further away from the cylinder, like the window frames in here, they are not unwrapped to scale, of course. And you can see that they are still bent, and really only what has been on the surface of the cylinder will be unwrapped to scale. So this is an important thing to keep in mind. So now I've just demonstrated how you can unwrap photographs using Poinson's heritage, but you can also unwrap the point cloud itself if you don't have oriented photographs. So let me demonstrate this one also to you. I will just open another drawing without photographs, and you can see the cylinders already fit in here, and I don't have any photographs in addition, so I will unwrap, create an unwrapped raster image of the point cloud itself. To do so, I will first clip the point cloud to the part which I really want to unwrap. So please note that we have some really nice tools for clipping. I can define a circular shell, and I will do so. I will select some objects with the object snap, F4, point cloud node, okay, and pick 3 points to create the shell, and specify the first radius to get these inner points cropped, and another shell to crop a bit of the outer points over here, and what's inside this shell will still be there. Okay. See, we still have some parts which we don't need, but we can get rid of those very easily. Using the rectangular clip. Okay. I just name the section so I can come back to it if I want to. And all I'll do now is, in order to use this part of the point cloud, I need to create a so-called smart section using this button. I convert it to a temporary Qubit point cloud file. Takes just a few seconds, and here we go. And now I can once more go to Points Heritage, to image computation, unwrap cylinder, like we used with the photographs, same dialog. And like before, we will just select cylinder outside. Now we need to use a 3D point projected to the cylinder surface, which we want to select. And we have to enable the object snap again. So I pick that point over here, and software calculates the intersection with the cylinder surface as a reference point. Once more I have the settings like before, and I again just want to place it at the cylinder and type in the 2.3 was a good number. And again, if I would have some geometry on top of the surface, I would choose this and could select the objects in the drawing, but I don't have some. And now we don't have image data, but we do have a Qubit point cloud, which we just created with the smart section. So we can add this one by picking the boundary box or picking the point cloud itself, confirming, pressing enter. Brightness correction is not necessary right now, and yeah, we just say unwound point cloud, save it, and we can check the resolution of the imagery. Okay, 2 millimeters is quite small, like this. Depending on the resolution of the point cloud, we can still, as the resolution of the point cloud is less than 3 millimeters, but 5 millimeters, it's sufficient to have 5 millimeter raster image. If I say OK, you see that the size of the image has been reduced, and I will start to compute the projection, and you will see the results soon. I will skip that part right here and show you the result in a second. Yeah, and once it's finished, I'm once more asked if I want to switch to the plan view of the unwrapped image. I say yes. Software will put me to the image, and you can see, as good as quality of the point cloud was, I get a nice raster image, which is placed in front of the point cloud and the cylinder. And yeah, and once more I can pick true length from the unwrapped imagery. Let me just show you how you can switch back from the smart section to the entire point cloud. You just pick the option set current point cloud, and smart section will be disabled, and you're back to the true point cloud over here and able to access the section manager once more if you want to. So that is what I wanted to show you. Thank you for your attention, and bye till the next time.